Look up at the night sky, and you're seeing a masterclass in isolation. The spaces between the stars are unimaginably deep, dark, and empty. We have walked on the moon, landed rovers on Mars, dropped probes into Saturn's orbit, but these triumphs are strictly local. The simple truth is, we are trapped. To reach even the closest neighboring star system using the fastest spacecraft we have ever engineered would take tens of thousands of years. Because we cannot go out into the deep to touch the stars, our only chance to study another solar system is to wait for the rare moments a stray piece of one washes up on our shores. In July of 2025, a network of telescopes called ATLAS caught a faint smudge drifting across the sky. It was tiny, glowing at a barely visible 18th magnitude, but it was tearing through space at 61 kilometers every single second. This diagram illustrates the difference. Every local comet is locked into a closed loop around the sun. But this smudge rode a wide, open curve, a hyperbola. With that specific angle, the sun's gravity is powerless to catch it. It is an interstellar wanderer, 3I/Atlas. As 3I/Atlas approached the sun, its frozen surface began to warm and release gas, allowing telescopes to analyze its chemistry. They found water, but the chemical signature of that water revealed a significant anomaly. The ice packed inside this tiny, dirty snowball was forged long before our sun even existed. It raises a difficult question. How does a drop of water manage to be older than the star lighting up our entire sky? In early November of 2025, scientists pointed the massive radio dishes of the ALMA observatory in Chile toward the glowing cloud of gas surrounding the comet. They were searching for deuterium. Most water is made of standard hydrogen and oxygen, but occasionally a heavier version of hydrogen, an atom with an extra neutron in its core, takes its place to form semi-heavy water. This animated model shows how that heavy molecule acts as a permanent birth certificate. The ratio of heavy to normal water locks in the exact temperature of the cold cloud where it first froze. The ALMA data showed that 3I Atlas is 30 to 40 times richer in heavy water than the oceans here on Earth. That kind of deuterium saturation requires extreme cold, a deep freeze below 30 Kelvin, far colder than the dark outer edges of our own solar system. Other oddities followed. Observations from the Subaru telescope and a facility in Hawaii picked up strange ratios of carbon dioxide to water, traces of methane, hydrogen cyanide, and a cloud of nickel gas completely separated from the iron that normally accompanies it. This combination of extreme cold and specific gases indicates that the comet's ingredients were assembled under a set of rules different from those that built our planets. To find the age of a comet moving at 200,000 kilometers an hour, we have to look at how it cuts through the larger patterns of the galaxy. This diagram of the Milky Way galaxy reveals its layered structure. The flat central band is the thin disk, a neighborhood of younger stars where our sun lives. Enveloping that is the thick disk, a puffier layer filled with ancient stars that formed shortly after the galaxy began to take shape. By tracing the exact angle and speed of 3I Atlas, a team at the University of Oxford found that its path completely ignores the young, flat plane of our neighborhood. It belongs to the older, scattered population of the thick disk. Based on that trajectory, researchers place the comet's age somewhere between 3 and 12 billion years. It is the oldest comet humanity has ever observed. Long before the Earth coalesced from dust, before our sun ever ignited, this frozen wanderer was already drifting alone in the dark. Its age carries a harsh mathematical reality. Any star old enough to populate the thick disk has had more than enough time to burn through its fuel and die. The sun that forged this ice is almost certainly gone. 3I Atlas is a relic, a single surviving fragment of a world that no longer exists. It was set loose when its parent star died, drifting for billions of years until its path finally crossed ours. Until now, everything we knew about how worlds form and how water pools has been based on exactly one example. We have only ever had access to the chemistry of our own solar system. Now we have a direct physical reading from a second planetary system, and its heavy, ancient water suggests that the universe was building worlds using completely different recipes billions of years before we existed. Today, 3I Atlas is already climbing back out of our neighborhood. It is racing along that same open curve, fading from the lenses of our largest telescopes, and it will never return. We had only a few brief months to catch a glimpse of a traveler that has been on an unbroken journey since long before the Earth was born. If a single random visitor can carry a history this strange and this old, it suggests a vast number of other ancient wanderers currently drift silently in the dark spaces between the stars. The real gift of 3I/Atlas is the quiet reminder it leaves in its wake. Our galaxy is vast and deep, populated by the survivors of worlds that vanished long ago.